طيب بسم الله الرحمن الرحيم. So welcome to our last module. In this module, we're going to talk about recursion. Recursion is a new concept. So we didn't learn about the idea of recursion until now. It's a new and it's fun. And I hope that you enjoy the lecture as much as I have enjoyed preparing for it. It's going to be, inshallah, a short lecture. So, what is recursion? Let's move to the concept. So, what is recursion? Recursion is just a method, okay, that will solve a problem by calling itself repeatedly, so more than one time. So you have a problem and you are going to solve this problem using a Java code. And in your Java code, you will write a method, and that method will call itself repeatedly to solve this problem. So this is recursion. Recursion means a method that called itself more than one time. Okay, so that's just the concept. Very easy, very straightforward. So recursive method, what are recursive method? Is just a method that will call itself either directly. Directly means that the method will have a call inside itself that will call itself. So what is that supposed to mean? You have a method called A, and inside A, there is another call for the same method A. So here you have a recursion because you have a method that calls itself. And this is a direct call because the method itself is calling itself. Okay? Also, the recursion can happen when the method calls itself indirectly. How can a method call itself indirectly? Through another method. So A has a call to B. So method A will call B, and method B will call A again. So here is also a recursion. There is a method that will call itself, but indirectly through another method. So A will call B, and B will call A again. So another way of recursion. In recursion, or in order for the recursion to happen, you need something that's called a base case, and you need something else, which is the recursive call, or sometimes you can call it a recursive step. You need these two important things in order to make the recursive happening. But let's take an example, and in this example, we will understand fully what's the base case and what's a recursive call and how the whole recursive thing is working out. Factorials. I'm not sure if you're familiar with the concept of factorials, if you've studied this in math before or not. So what is a factorial? If you have a number like 3 and you want to know the factorial of 3, it means that 3 multiplied by 2 multiplied by 1. So how much is this? 3 by 2 is 6. 6 by 1 is 6. So the factorial of 3 is 1. If you want the factorial of any number, it is simply that number multiplied by the number minus 1 multiplied by the number minus 2 until you reach 1. For example, if you want the factorial of 5, just we're going to replace the n with 5. So it is just the multiplication of 5 multiplied by n minus 1 means 4. So 4 multiplied by n minus 2, which is 5 minus 2, which is 3, multiplied by 5 minus 3, which is 2, multiplied by 5 minus 4, which is 1. So we stop when we reach at 1. So this is the factorial of 5. And we need to write a Java code that will calculate this factorial recursively, because you are multiplying these numbers by themselves. So you need a recursive method to do this job. And you are going to stop when you reach 1. Okay? So the factorial of a positive integer number n is just written like this, and then the exclamation mark, and it's just this equation over here, which is a thing that I've just explained for you. If you want to calculate the factorial of 5, the recursion, or the whole idea behind the recursion or the recursive method is that it is going to take a big problem and break it into a smaller pieces, so it's easier for the Java to solve this problem. So instead of having a big problem like the factorial of 5, this problem is going to be broken down or broke down into multiple steps or smaller problems that will help solve this problem in an easier way. So if I want to get the factorial of 5, the factorial of 5 is just 5, as we said, 5 multiplied by the factorial of 4. So the factorial of 5 is just 5 multiplied by the factorial of 4. Okay, but I don't know what is the factorial of 4. So the factorial of 4 is 4 multiplied by the factorial of 3. So I don't know the factorial of 3. So the factorial of 3 is just 3 multiplied by the factorial of 2. I don't know the factorial of 2. So the factorial of 2 is just 2 multiplied by the factorial of 1. And the factorial of 1 is equal to 1, and I will stop here. So the recursive sequence will stop when I reach to 1. This is what is happening over here in this line. If you want the factorial of 5, you need to break this big problem into a smaller problems. And these are the steps of my smaller problems. The factorial of 5 is just 5 multiplied by the factorial of 4, but you don't know the factorial of 4. So you need to make another call, so the recursive method needs to call itself. Why? Because it needs to find what is the factorial of 4. The factorial of 4 is just the multiplication of 4 by the factorial of 3. So because we don't know what is the factorial of 3, the recursive method needs to call itself, because it needs to go and find what is the factorial of 3. The factorial of 3 is 3 multiplied by the factorial of 2. Because we don't know what's the factorial of 2, this method needs to call itself again to find the factorial of 2. Because we don't know the factorial of 2 is just 2 multiplied by 1. And the factorial of 1 is 1. So how many call did we make? 1, 2, 3, 4, 5. So with this sequence of recursive calls, we'll stop when I reach 1. So what happens when I reach 1? Now I'm going to return the values to the calls that just happened. I have 1 over here, so I will return 1 to this call. And instead of factorial 1, I will have just 1. So 2 multiplied by 1, the answer is 2. So I have 2. Now, I will return 2 to the factorial of 2. So instead of 2, of a factorial of 2, I will have now 2. So 2 multiplied by 3 is 6. Now I have 6. I will return 6 to over here. Where exactly? To the place of the factorial 3, because I've called from this factor. The factorial 3 is the one that's called the one that calls the function call. So instead factorial 3, I have 6. So now 4 multiplied by 6 is 24. I will return 4 to this over here. So, sorry, 24. So instead of factorial 4, I have now 24. 5 multiplied by 24 is 120. So I will return 120 instead of this. So the answer of factorial 4 is 120. Easy peasy. Always you are going to have a sequence of recursive calls when the function keep calling itself. When the calls or the sequence of the calls will stop when you reach something called a base case. So in recursive, you're always going to have two things. A base case, which is very important in order to stop the sequence of the function's calls. If you don't have a base case, then this sequence of function calls, when the function keeps calling itself, will never stop. So you need something to make the sequenceable calls stop, the recursion to stop, which is the base case. The base case in our example here in the factorial is when you reach number 1. Also, you have the recursive called the recursive steps, which is the sequence over here when the method keep calling itself. Once you reach the base case, when the recursive calls or the sequence has stopped, now you are going to start returning the value until you reach to your final answer. Very easy. Let's see how does this happen in coding. Bad easy. Let's start looking at here. This is our main. In the main, you don't have anything apart from you want to print out the result or the return the return value of them from the function called factorial 3. So you are going to call the function and the function is called factorial, and you're going to send number 3 to the function. Okay. Now, this function call will call this method over here. So this is the factorial method. It will return a long number. A long number is just an integer number that will have a more space in the memory. So the int will have this space in the memory, but the long will have this space in memory. So it just occupies a larger space in memory. طيب. It will receive a number. Also, the number is long. The number is long, which is 3. You've sent 3. 3 is here. 3, the number. The first thing you need to do when you start the recursion method is to check have you reached the base case or not. So the first thing I'm going to do is check, is the number that you have, which is 3, less than or equal to 1? Have we reached the base case? And our base case now, it says that if you reach 1 or reach 0, I'm going to always return 1. Okay, so when the number is less or equal to 1, I'll return 1. So this is my base case, so I will return 1. Else, if my number is not 1 or 0, I will return the number multiplied by the factorial of the number minus 1. Let's take an example. And we are we're going to take the example over here. This is exactly the same code as above, but instead of long, they used int, and instead of number, they used n, and that's it. So this is your call. You started from here. This is the call you have. This is the method. The method, you have n, and n has 3 inside of it. طيب. So n is 3. The first thing you need to do is check. Is the number inside n less than or equal to 1? So no, it is 3. So the if will not happen. We're going to check the else. What does the else do? Return n, which is 3 multiplied by, go and call the function factorial again, and this time with 3 minus 1, which is 2. So here the recursion will happen. This is a recursive call. The method is calling itself. The factorial method is calling itself again. So inside the same method, there is a call for the same method. طيب, now I'm calling factorial with 2. So n now is 2. Once I go inside the method, I'm going to check. Is 2 less than, I'm going to check my base case. Is 2 less than or equal to 1? No, it's not. So I'm going to try the else. The else says, please return for me n, which is 2, multiplied by factorial with 2 minus 1, which is 1. Right? This will make a recursive call. And once I go, the n now is 1. So let's check the base case. The base case says, if n, which is now 1, is less than or equal to 1, yes, it's true. It is less than or equal to 1, and I'm going to return 1. So 1 was returned. Let's change the colors. 1 was returned to here. So 1 is here. So 2 multiplied by 1 is 2. So the 2 will return to this call. So instead of this call, I will have 2. So 3 multiplied by 2 is 6. So at the end, this call, the main call, will have, instead of this, the return is 6, and will print for me that the factorial of 3 is 6. Okay? Always remember that when you reach the base case, then the recursive calls will end and you will start returning the values step by step by step. طيب. If you want to make this method a little bit more interesting, or this program or code a little bit more interesting, you could put the print. Let's change the color. The print statement over here inside a for loop that will start from 0 until 21. So it will loop from 0 until 21. And each time it is going to call the factorial with the counter. What is the counter? Is the number here. The first time is going to be 0, and the second time is going to be 1 until 21. Why? Each time it will print the factorial of the number. The factorial of 0 is 1, factorial of 1 is 1, the factorial of 2 is 2, factorial of 3 is 6, and so on, until we reach 21. So we're just making a loop in order to find the factorial of not just one number, of multiple numbers, and printing out these results. If you are installing any of the Java IDE into your device, and you want to code this factorial program using your IDE, and you want to see exactly what's happening behind the behind the scene, you can use something called, or you can debug your program. You can debug your program using something called a breakpoint. What does a breakpoint do in your IDE, in your program that you are using to code or to write your Java code? It's just simply instead of your running your app, so when you run your app, you will have your result directly. So the factorial of 3 will be 6 directly. And you don't know what's happening behind the scene, what the Java editor is doing exactly, or the compiler is doing exactly. If you want to know what's doing exactly, you can place a breakpoint over here in the factorial, in the line where is the factorial call. So every time your compiler is calling or executing this line, the execution will stop to show you exactly what's happening. So if you compile your program with a breakpoint, you will have something like this that's showing you how many times this factorial method was called and what are the results. In this way, you'll see that every time you hit the step into button, the method will be called again and again and again until it reaches the base case and the calling will stop, or the recursion will stop. So behind the scene, these are all the calls that happened in order to, so 6 calls that happened in order to find the factorial of 5, which is 120. So it's just a way of debugging when you're using your IDE in your own computer and you want to see exactly what is happening step by step. طيب, let's take another example, which is the Fibonacci. I think it's pronounced like this, or Fibonacci. Fibonacci. I think it's pronounced like this. طيب, what's the Fibonacci series? It's a sequence of numbers where each number is just the sum of the previous two. It's like a puzzle. You have a sequence of numbers, and each number is the sum of the previous two. So you have the two base numbers, which is 0 and then 1. Then you have 1. 1 is just the summation of 0 and 1. So you have 0 at the start and then 1. Then the third number is just the sum, حاصل جمع, the 0 and 1, which is 1. Now, the summation of the last two numbers, which is 1 and 1, is 2. 2 and 1 will result in 3. 3 and 2 will result in 5. 5 and 3 will result in 8. 8 and 5 will result in 13. 13 and 8 will result in 21, and so on. This is called a Fibonacci series, and the series is happening, in order to code the series, you probably need to use recursion, because you need a recursive call to the method. The series, as we said, it is just a subsequent calls of the numbers. So it's just the sum of the previous, each number is the sum of the previous two numbers. Very easy, very straightforward. In this series, you need, if you want to do or to solve this Fibonacci series using recursion in Java, you need, of course, two things, which are the base case and the recursive call. This is our recursive call. The Fibonacci of n is the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. This is your recursive call. And you need the base case. The base case in here is 2. Why? Because the Fibonacci of 0 will always be 0, and the Fibonacci of 1 will always be 1. So you have here two base case. These two base case will result in stopping the recursive calls. Okay, let's take an example, or let's see what's happening in the code. In the code, this is your Fibonacci code. Let's change the color into blue. This is your main method. It starts here. You are going to have a counter. The counter starts from 0 to 40. Why? And every time you are just going to print out the result of the Fibonacci of a number. So the first time you want the Fibonacci of 0, then you want the Fibonacci of 1, until you ask for the Fibonacci of 40. So you are going to print out an output like this. You want the Fibonacci of 0, which is 0, Fibonacci of 1 is 1, Fibonacci of 2 is 1, 3 is 2, and so on. Right. What exactly are these numbers? Because the Fibonacci is just a fixed series, which is like this. So each number is just a summation of the two numbers that are before the previous two numbers. So when you ask the Fibonacci of a number, you are in your program, what you're asking for is this. So these are the value: 1, the Fibonacci of 0 and 1, and then the Fibonacci of 1, this is 1, and then 2, which is 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and so on. So the value, it's your Fibonacci series. And you have the indexes. The indexes is like an array indexes, start from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. So if I want the Fibonacci of 0, then I'm asking for this, for the index, for this. If I want, so I'm technically asking, what is the Fibonacci at index 0? The Fibonacci at index 0 is 0. If I'm asking for the Fibonacci 1, then I'm asking what is the Fibonacci at index 1, which is 1. If I'm asking about the Fibonacci of 2, then I'm telling my program, please give me the Fibonacci number at the index 2, which is 1. If you want the Fibonacci of 3, then at index 3, what is the Fibonacci number? Is 2. If you want, look at the output. If you want the Fibonacci of 7, then you are going to check at the number. In the index 7, what is the value? Is 13. So the Fibonacci is 13. So if you, in case you are wondering where these numbers from, then I have just explained to you where these numbers from. The series is fixed. Each number is the summation حاصل جمع الرقمين اللي قبله. وعندك indexes مقابلة لهذه الأرقام. لما تسألين عن الفايبونيشي نمبر تستخدمين الاندكس. أنا أبغى الفايبونيشي نمبر اللي موجود في اندكس 11، إذا هو 89. هذا هو فايبونيشي نمبر للاندكس مو موجود 11، مع الأسف الأوتبوت مقطوع هنا. طيب الفايبونيشي نمبر للاندكس رقم 10 هو 55. يس، هو 55. فالكود انت بتعطين له الاندكسز، وهو بيعطيكي ايش الفايبونيشي نمبر اللي موجود في هذا الاندكس، لان السيريس هذه is fixed, can't be changed. Okay, طيب let's see the code. You're having, as I said, for loop because you're asking about what are the Fibonacci numbers in the indexes starting from 0 to all the way to 14. Then you are going to call the Fibonacci method, and You're not just going to use today the primitive types like int or long. No, you are going to use a special kind of integer number. Let me just plug my charger. Just a second. So you need not just an int and long, you need a special type of integer number that will hold a bigger space in memory. As we said, int hold this space in memory, long hold this space in memory. You need another data type that's also integer but hold a bigger space in memory. Why? Because the Fibonacci numbers can grow large, very big. So the Fibonacci of 40 is a very big number. The Fibonacci of 39 is a long, long number. Fibonacci of 38 is a long, long number. To make sure that all these digits are stored in the memory, we need a data type that's big. And this data type is called big integer, and you are going to import it using the math library. So from big integer, bring for me the value of counter. You're taking the counter over here and you are going to convert it into a big integer. So the first time the counter is going to be 0, the second call the counter will be 1 and then 2 and then 3 and so on. Let's imagine that you have called the Fibonacci with the counter being 3. So what's going to happen? You called Fibonacci with big integer dot of value. So I want number 3 as a data type that's called big integer. Please go and put it for me inside here. So look, the Fibonacci has a variable called number. Now it's going to have 3 and it's with data type big integer. So the data type it is for it is big integer. Before we go deep in this method, there is also a static integer over here, or a static big integer. We called it 2. So this is 2, like this. It's of type big integer, and it's hold the value of 2. So inside 2, you have 2. And inside number, you have 3. And this 2 is static, so you can't change the value inside 2. Like the first thing you do when you step inside a recursive method is to check for the case, the base case. The base case says we have 2 base cases. If the Fibonacci of 0 is 0, we are going to return 0. If the Fibonacci of 1 is 1, we're going to return 1. Because in the series over here, as we said, in the index of 0, the value is 1. And in the index of 1, the value is 1. In the index of 0, the value of 0. And then index 1, the value that you should return is 1. Right. So we're going to check these things. Since you use here a big integer, then you can't mix and match. You can use integer or you can't use long anymore. You need to be consistent with all the data type you're using. So because we're using a big integer here, all of the other integers we're using needs to be also big integer. For this reason, we are asking if أول شيء you need big integer dot 0. So this is just basically you are asking for 0. And because it's of the type big integer, you can't ask is number equal to to big integer dot zero, you can't ask this question. Why? Because when you have a big integer and the number also of a big integer, you can't use equal equal. You need to use dot equals method. So the comparison needs to happen this way. If number, which is 3, dot equals to big number dot 0, which is basically saying 0. Is this true? No, this is false. Or you're checking for another case. The other case is the number, which is 3, dot equals to big integer, which is 1? No. So both of them is false. This is why you're going to go to the else part. What does the else part say? Return the Fibonacci of a number dot. So as I said, because I'm using big integer, then I can't use the normal minus and the normal plus sign or sum. I need to use the method that are dedicated to do the same. So if you need to subtract a value of number, then you are using the dot subtract method. So number dot subtract. Subtract, how much do you want to subtract? I want to subtract by 1. And because it's a big integer, you can't just say 1. No, you need to say big integer dot 1 because all of the data type need to be the same. So here, basically, you're just saying take 3 and subtract 3 minus 1. So you have 2 over here. So here you have 2. Dot, you're saying at Fibonacci number dot subtract 2. So also go and make another Fibonacci call, taking the number, which is 3, and subtract 2 from it. So 3 minus 2, which is now equal to 1. And when you finish and give me the return, we're going to do an add. Add is just a summation. So to make this easier for you, this is the first call. You called the Fibonacci with the number 3, and this call made another 2 separate calls, one with 2 and one with 1, exactly like we said here. So the first call it was 2, and the second call is with 1, and there is an add between them. So an add summation between them. This call will return 1. Why? Because it will hit this base case. This base case says if the number, which is 1 now, dot equal to big integer dot 0, this is 0, so this is false. But this one, number dot equal big integer 1. So 1 is equal to 1. So this one is 1, and there will be no more calls over here. This will stop this side of the tree of the recursive call, and the sequence of the part of the tree will stop. However, this call will cause another 2 calls for Fibonacci of 1 and Fibonacci of 0. This call will return 1, and this call will return 0 because they will hit these base cases. Right. After that, we're going to return. What are we going to return? The 1 will be returned here. So here will be 1. 0 will be here. This is 0. 1 plus 0 is 1. So we are going to return 1 over here. بعدين, this is 1. We are going to return 1 here. And we have a plus sign here. So 1 plus 1 is 2. So the answer of Fibonacci of 3 is 2. Is it correct? Let's see. So in index 3, the Fibonacci of 2. So yes, it is correct. You just need to trace your code step by step, and inshallah, once you trace the way I'm doing it, it will be clear. The most important thing you need to know is that the recursion, it means a method that's calling itself. In order to make the recursion happens, you need two things. You need a method that will call itself, and you need the base case. The base case is responsible for making the recursion stops. Otherwise, the recursion will continue to happen and will never stop. Okay? طيب. Some of you might think or might wonder, like, what is the difference between recursion and iteration? Recursion might look a little bit similar to iteration. What is the difference? In iteration, we are using repetition structures. Like what are repetition structures? Like for loop or a while loop or a do while loop. So we are using loops like for and while and do while. And recursion, we're not doing loops. No, we are using selection structures like if and if else, and we can also use switch. In all of our recursion codes, look, we've used if and if else, and even with the factorial, we used if and else. So in the recursion, we don't use the for structures, and instead, or the loop structures. Instead, we use the selection structures, which are if and if else, and switch. In the iteration, the repetition happen explicitly using the repetition structure. So you know there is a loop happening because you have used a repetition structure like for or while or do while. However, the repetition happen in recursion through repeated method calls. When the method in recursion keeps calling itself, here the loops is happening, or the iterative call, or the iterative behavior is happening because the method keeps calling itself. In the iteration terminates when the loop continuation condition fails. When the for loop going to stop, when this condition over here becomes false, then the loop will stop. However, in recursion, no. It will terminate when the base case is satisfied. When you reach the base case, for example, this is my base case in the factorial code. When you reach the base case, when the base case is true, then the recursion will stop. In the iteration, you control the repetition by using a counter. You control how many loop or how many iteration you want using the counter. For example, the counter here is I, and you control how many times you want this loop to happen. In the recursion, the control of the repetition happen by dividing the problem into simpler ones. يعني if you're asking for the for example, the factorial of 0, or the factorial of 1 or 2 or 3, each of them, the repetition will happen for different times. For example, this you only have one call. Here, I think one call. Here, maybe you have two calls. Here, you have 6 calls, and so on. So the number of repetition depends on the number you're sending. Factorial 5 different from 4, different from 3. So the number of repetitions is different بناء على إيش المشكلة اللي عندك. لما تبين الفاكتوريال 5 معناته 5 عدد كبير، فمعناته تحتاج تسوي شغل أكثر، معناته بتنادي نفسها أكثر عدد من المرات. إذا تبين فاكتوريال of 1 معناته الريبيتيشن عددها قليلة لأن 1 عدد صغير، معناته عدد المرات اللي بتنادي فيها الفانكشن نفسها بيكون أقل and so on. So ما تحكمي فيها بعداد زي الفور لوب، لا، على حسب المشكلة اللي عندك وطبيعة الأرقام اللي عندك. Recursion more overhead يعني slower than iteration. إذا استخدمتي if you use the recursion instead of iteration, it means you have a slower performance. Also, it uses memory more, so it's memory intensive. It needs more memory than the loops. Anything that can be solved iteratively can be solved also using the recursion. So the same problem that you solve it using the recursion, you can also solve it using the iteration, so using the normal loops. Then why do we use recursion? Because sometimes if you have the same problem and you have write the code to solve it with iteration and in recursion, you will find that the code in recursion in some problems is a few lines shorter, so it's shorter and simpler than the code that you will need to write using the iteration. Also, in some programming languages like Prolog is one of the AI, artificial intelligence languages. There is no iteration structures, so there is no loops. There is no for and while and do while. If you want to do a loop in a language like Prolog, you are going to need to use repetition instead of the loops. So in some programming language, there are no iteration or repetition structures, and instead you need to use recursion. So it's wise if you learn what is a recursion and what's the difference between recursion and the iteration. As I said, any problem that's solved with recursion can be solved with iteration. So this is the factorial program solved with loops instead of recursion. You can try it yourself. You can write the code one time with recursion and one time with a loop. So here it's with a for loop, and you will see that the output is going to be exactly the same. طيب. The last thing is the problem of the Tower of Hanoi. I'm not going to go through this problem. If you want to learn more, you just need to go through this website or this website and learn about this problem a little bit more. The whole idea is that this problem usually solved using recursion. You will have a three stacks, so three stacks like this, ثلاث أعمدة, and you have three desks, and you need to move all the desk from the tower number 1 into the tower number 3 in a specific order. So the green one, the larger desk, need to be at the bottom, and the medium desk need to be in the middle, and the smaller one need to be in the top. They always need to be in that order. You need to stack them in this order. الكبير تحت، الصغير في النص، والكبير عفوا الميديم الوسط في النص، والصغير on the top في الأعلى. So you can't place a larger desk onto a smaller desk. ما أقدر أحط واحد كبير والصغير تحت. This is wrong. So you need to do this using 3 towers and moving them from tower 1 to tower 3. And this is a recursive problem that can be solved using recursion. Until now, or until here, we have finished, alhamdulillah, thankfully, module 13 and all of the OOP material. Inshallah, your final exam يا رب يكون straightforward and easy for you to solve. Inshallah, your whole semester with me was straightforward, and I was يعني لطيفة معكم، وصلت لكم المفاهيم as much as I can. If you have a problem or if there is any concept you don't understand, you can contact me before your final exam, and inshallah I will reply and help. Good luck, and it was very pleasure to be your teacher during this semester. Thank you so much.